Okay, think about this. Right now, we can talk to pretty much anyone, anywhere on Earth, almost instantly. Fiber optics, satellites, 5G. It's amazing.
It really is. We take it completely for granted.
Totally. But now, imagine trying to do that in space. The further out you go, the slower everything gets. Even light speed isn't fast enough.
Right. That's the crux of it.
I mean, a message to Alpha Centauri, over 4 years. One way. It really puts our need for instant updates into perspective, doesn't it?
It absolutely does. And it raises a huge question. How can we possibly explore or, colonize space if we're cut off by these massive time delays? What does connection even mean then?
Yeah, 4-year lag for hello, that's not really a conversation.
Exactly. It's more like sending messages in bottles across an ocean of time.
So that's the big challenge. And today, in this deep dive, we're going right to the edge. We're looking at theoretical physics, speculative engineering.
The really fun stuff.
The really fun stuff. We're trying to understand this idea of a galactic warp web, like a network of warp relays for faster-than-light communication, maybe even travel.
And what that could actually mean for us, for humanity's future.
Let's get into it.
Okay, so the basic problem, the reason we even need to think about warp drives, comes down to Einstein.
Right. Good old relativity.
Yep. His theory basically sets a cosmic speed limit. Nothing with mass can go faster than light in a vacuum. That's 299,792 kilometers per second. Fixed.
The universe's ultimate speed bump.
Pretty much. And it's woven into the fabric of space-time itself. It's not just a technological limit we can engineer our way past easily.
And those delays, when you actually put numbers on them, they're just staggering. We mentioned Alpha Centauri, but even Mars.
Mars can be anywhere from 4 to 24 minutes away, light speed delay. So forget a quick chat with Martian explorers.
Right. A 40-minute round trip for, how's it going? Fine.
Exactly. And Proxima Centauri, our nearest star system neighbor, 4.25 years. Like you said, one way.
So a PhD thesis could be completed between asking a question and getting the answer.
Easily. And across our own galaxy, we're talking tens of thousands of years.
Oh, okay.
So this isn't just annoying, it fundamentally breaks the idea of an interstellar civilization. Colonies would be utterly isolated by time. You could have a crisis on Proxima b, and Earth wouldn't even know about it for over 4 years, let alone send help.
Help arrives 8.5 years later.
Yeah.
Maybe.
So you need a loophole. You need a way around that speed limit if you want any kind of connected future out there.
Which brings us to the famous one, the Alcubierre warp drive. Miguel Alcubierre, 1994. It made quite a splash, didn't it? Sounds like pure sci-fi.
It does, but the fascinating thing is it's actually derived from Einstein's own equations. It's a theoretical possibility within general relativity.
How does that work? Bending the rules without breaking them.
Kind of. The core idea is really clever. Instead of the ship breaking the speed limit by moving through space faster than light.
Which Einstein says is a no-no.
Exactly. The Alcubierre concept involves warping space-time around the ship. You create this warp bubble. Inside, space contracts in front of the ship.
Pulling it forward.
Sort of. And space expands behind it, pushing it along. The ship itself stays still inside its local bubble, but the bubble moves, carrying the ship with it, potentially faster than light relative to the outside universe.
So the ship isn't speeding, the road is moving. Like one of those airport walkways.
That's a great analogy, actually, yes. The ship is standing still on the walkway, but the walkway itself is moving very, very fast.
Okay, that's a genius. But there have to be catches, right? It sounds too good to be true.
Oh, there are major catches, big ones. The number one problem is you need something called exotic matter. Matter with negative energy density or negative mass.
We don't have any of that lying around.
We've never observed it, not in the quantities needed. We're not even 100% sure it can exist like that. It might violate certain energy conditions in physics.
Okay, hurdle number 1. Find or make magic matter. What else?
Well, there's the potential for causality violations, time paradoxes.
That's what I read.
Generally frowned upon in physics, yes. You could, in theory, arrive before you left from certain reference frames. And then there's the minor issue of potentially accumulating a massive amount of high-energy particles on the front of the bubble, which would then be released catastrophically when the drive turns off. You might vaporize your destination.
So arriving is problematic.
Very. So, yeah, huge challenges for a single ship just deciding to warp somewhere.
But there's been some newer research.
Yeah.
Trying to get around these problems.
Yes, exactly. People haven't given up. Recent studies, like some work by Bobrick and Martier, are exploring if similar warp-like effects could be achieved with, let's say, less exotic requirements. maybe using known physics in clever ways.
So dialing back the magic matter requirement.
Potentially. Or finding ways to structure the warp field differently. It gives us a little glimmer, suggesting maybe it's not completely impossible down the line.
And that glimmer lets us think bigger, right? Not just one ship, but a network.
Precisely. If we can figure out the core mechanism, even if it's difficult, maybe we don't need every ship to carry its own warp engine. Maybe we build infrastructure.
Okay, so what is a warp relay then? If it's not just a ship, what does it do?
Think of it like a stationary node in space, a piece of infrastructure. Its job is to locally bend space-time.
Create the warp effect.
Create or manipulate the warp effect, yeah. To relay ships, or maybe even just signals through these warp channels, and critically to keep everything synchronized across these vast distances.
How might that actually work? I mean, conceptually.
Well, there are a few ideas floating around, all pretty speculative, of course. One way is it could be like a mini stationary warp bubble generator. The ship flies near, the relay engages, creates a localized warp field pointing to the next relay, and off the ship goes.
Like stations passing the baton.
Exactly. Or another idea, maybe it's more like a wormhole stabilizer.
Wormholes, another sci-fi favorite.
Right. But here, maybe the relay isn't creating the wormhole from scratch each time, but it's maintaining a pre-existing stable connection between 2 points, 2 relays holding a tunnel open.
That sounds potentially more stable? Maybe.
Maybe. Or maybe even weirder, quantum entanglement.
Okay, now you're really going theoretical.
We are. But imagine if relays weren't physically linked by warp space or wormholes, but by quantum entanglement. You affect one relay and another, light years away, instantly mirrors that change.
For signals, you mean? Instant communication.
Potentially. True instantaneous signaling. It bypasses travel time altogether. You'd need some serious breakthroughs in quantum gravity, but it's on the table theoretically.
So miniature warp bubbles, stable wormholes, or quantum entanglement hubs. Lots of options, all needing physics we don't have yet.
Pretty much. But it defines the target.
Okay, so building this warp web, what kind of hardware are we talking about? This sounds like the biggest project ever conceived.
Oh, absolutely. First, you need power. Unbelievable amounts of power. Stationary power sources. Maybe you harness a star.
Dyson sphere territory.
Could be. Or maybe controlled fusion, or perhaps even an artificial black hole, if you could manage that. Something immense.
Okay, power source. Check. What else?
Gravitational anchors. You need to hold these things in place and manipulate space-time precisely, maybe at Lagrange points. Those stable spots between planets or stars.
Makes sense. Stable location.
And sensors. You'd need incredibly sophisticated space-time sensors to monitor and adjust the curvature in real time. It's not a static thing.
And something coordinating it all. You can't just have ships warping willy-nilly.
Definitely not. You'd need a massively complex, probably AI-driven coordination lattice, routing traffic, ensuring safety, preventing collisions, or, space-time tearing events.
It's like, air traffic control for reality itself.
That's a good way to put it.
You used the analogy router satellites that warp space. I like that. It makes it feel almost graspable.
Right. It grounds it a bit. The function is familiar routing traffic, but the mechanism is bending the universe.
And incredibly, this isn't all just chalkboards in theory, right?
Yeah.
I heard NASA's EagleWorks lab actually did some experiments related to this. Warp field interferometry.
That's true. They did experiments using interferometers to see if they could detect tiny, tiny distortions in space-time that might be analogous to the kind of effects needed for a warp field.
And did they find anything? Proof of warp drive?
No, not proof of a working warp drive. The results were subtle and debated. But the key thing is they were looking. They were building experiments based on these theories. It shows that serious people are exploring the fundamental physics involved.
So it's not just science fiction. It's fringe science, maybe, but it's science.
Exactly. It's about asking the questions and testing the edges of what we know.
Okay, let's imagine we pull it off. Somehow, humanity builds this warp web. What happens then? How does that change everything?
Oh, fundamentally, everything changes. Think about colonization first.
Right, no more isolated outposts.
None. You could have colonies on planets light years away, but they could be in real-time communication with Earth. They could share data, synchronize clocks, get immediate support, a medical emergency. Earth doctors could assist in real time. A scientific breakthrough shared instantly.
It makes interstellar civilization actually possible. Coherent.
Exactly. It changes a colony from being a forgotten outpost to just another node on the network, like moving from remote villages to globally connected cities.
And what about society, security,
no.
warfare? If someone controls these relays,
That's the huge geopolitical or maybe galactopolitical question. Control the relays, you control the flow of ships, data, everything. You could isolate entire star systems.
the galactic firewall?
Or a weapon. Imagine weaponizing the energy involved or the space-time distortion itself. The potential for conflict, for control, it's immense. Who governs this network? Who ensures fair access?
Big questions. And philosophically, if we can do this, bend space-time to our will.
Yeah, what does that mean for us? Are we still just creatures evolved on one planet, subject to the laws of nature? Or do we become something else?
Yeah.
Co-authors of reality.
That's a heavy thought.
It really is. It shifts our place in the cosmos.
But with that kind of power, the risks must be equally huge. Not just the, oops, I vaporized my destination problem.
Absolutely. We're talking about manipulating the fabric of reality. What if we get it wrong? Could we accidentally, I don't know, tear space-time, create a runaway effect?
Like pulling a thread and unraveling the whole sweater.
Potentially. Or create those causality loops, paradoxes that undermine reality as we understand it. And like we said, the weaponization potential is terrifying on a scale we can barely imagine.
It really makes you pause. The internet changed humanity in, 30 years?
Yeah.
Fundamentally.
Yeah.
A warp web. It feels like it would redefine being human on an even deeper level. Our relationship with distance, with time, with the universe itself.
It would be a transformation unlike any other, a complete paradigm shift.
So wrapping this up, these warp relays, this whole idea, it's clearly way more than just a cool sci-fi gadget.
Definitely. It taps into something really fundamental about us, I think. That desire to connect, to overcome distance, to not be limited by our physical constraints.
It's the dream of transcending the cosmic speed limit.
Exactly. And yeah, the physics is incredibly hard, maybe impossible with what we know now. But asking the questions, doing the research, like at EagleWorks, that's the crucial first step, pushing those boundaries.
It really makes you think, if we ever did build this network, the galaxy wouldn't just be stars scattered in the dark anymore.
No, it would become a single place, a connected system, a unified civilization, maybe.
A galactic symphony, you could say. Wow, maybe the next giant leap isn't about reaching farther stars, but about mastering the space between them, mastering space-time itself.
That could very well be the next frontier, not distance, but space-time.